Hey guys, Mr. Middleton here. Today we're going to talk about simplifying radicals. We're going to do number radicals only. We'll do some more later. At the end of this video, you should be able to simplify radicals containing numbers, and you should be able to simplify the product of radicals. Alright, let's jump into it. To simplify, or to solve the equation x squared equals 50, we need to get rid of the exponent to get the variable by itself. Exponent. There we go. Okay, so this 2 here, this exponent stuff, and x being by itself. So, how do we do that? Well, we need to undo the squared term by using the square root. Okay? That's this thing. Okay? This is also called a radical. Okay. Just like addition undoes subtraction and division undoes multiplication, taking the square or the root, or we'll just say root, square root of a squared number undoes that squared term. So look what happens here when we have the square root of 13 squared. We'll see that square root square cancels out, gives us 13. Okay, and if we did this out, we'd have 13 times 13, the square root of 13 times 13 is the square root of 169. If you put the square root of 169 on your in your calculator, you'd get 13. Okay, the square root of 7,148 squared. Well, I'm not going to show you that that works out, but I see a square, I see a square root. Those are inverse operations. They cancel out. It'd be like me saying 7,148 times 2 divided by 2. Okay, I know that those two cancel out. Alright, so to solve the equation above, we would take the square root of both sides. And so when we take the square root of both sides, the square root and the squared exponent cancel out. And we are left with just x. Okay. However, radical 50 is not in simplest form, and that's what we're going to talk about today. Now let's do this. I'm going to misspell this word. Simplified radical form. Simplified radical. There we go. Form. Alright, and that's what we're going to be doing today. Alright, so let's talk about the properties of radicals and how we're going to use this. Okay, what this is saying is if I am multiplying two radicals together, we have radical A times radical B equals radical AB. If I'm multiplying two radicals together, I can multiply the two things under the radical to make one radical expression. So, radical 12 times radical 3, I can say, okay, well that's radical 12 times 3, because they're both underneath the radical. I can just kind of join them, and that'll give me radical 36. Okay, the converse of this property is also true. Okay, and what that means is if I have radical 36, I can change this and make it radical 12 times radical 3. Okay, and that's what we'll use. Okay, now one method for simplifying radicals is prime factorization. Okay, this is the one that I tend to use, and I do it in the form of a number tree. Okay. There's another method we can show you, but this is the method we'll be using. So, to show the prime factorization, what we do is we go through a number, and I'll just use a tree here with 50. Okay, and your rule for this number tree is find two numbers that multiply to give you this answer. Okay, and not a whole lot of thinking to it. I usually, if it's even, go with 5 or 2 divided by 2. So 25 times 2 gives me 50. And the only rule is you cannot use the number and you cannot use 1, which basically is the same number. Okay, so now I'm looking to see what two numbers multiply to give me 25. Well, two numbers that multiply to give me 25 are 5. Okay, and so here's my prime factorization: 5 and 5 and 2. Okay, let's do the same thing with 120. Okay, you can try this on your own and then check to see if your prime factorization is the same as me. you can choose any numbers that you want, but if you follow the rules that you don't use 1, then you'll come to the same answers. So I'll do 40 times 3, 20 times 2, 5 times 4, 2 times 2. Okay, and I stop anytime I'd have to use 1 or itself. So now my prime factorization looks like this: 2 times 2 times 2 times 3 times 5. Alright? So now how does prime factorization apply to radicals? This is the big idea you need to understand. Here's what we have. On the front, I have here, we saw the prime factorization of 50 was 5 times 5 times 2. Okay. When we are taking the simplifying a radical, what we will do is any pair of numbers, because look what we have 5 times 5. What is that? Well, that's 5 squared. 5 squared times 2. Okay, and this is just a reasoning of why it works. So that goes to, remember we can do the inverse or the converse of what we were talking about, because 5 squared times 2 is the same as radical 5 squared. It's radical 2. Well, here we see we have a radical and its exponent. That gives me 5 radical 2. Okay, so with all that, what you can notice is if you have a pair, then that pair goes to the outside. Okay, so let's do 120. Get 2 times 2 times 2 times 3 times 5. Alright, I see I have a pair of 2's. Now notice I have 2, 3, and 5. None of those are the same number though, so there's no pairing that we can do. So now on the outside I have 2, and left inside I have 2 times 3 times 5. And so now I'll just simplify that. 2 radical 2 times 3 is 6. 6 times 5 is 30. Alright? So, let's do 48 together, and then I'll ask you to do 2 and 3. Okay? So, 48, 16 times 3, 3 is prime. 4 times 4. Okay. And actually, I'll stop here. Okay. And I'm going to stop here because I see I have a pair of numbers, and that's really what I'm looking for. Since I have a pair, I'm going to stop. 4 times 4 times 3. I'm going to take this pair out. 4, and the 3 is left inside the radical. Alright. I'll do number 3 with you. Okay. I could do 4 times 4, but I want to show you how this works if I don't. Okay. 2 and 2. Okay, so notice I have all these 2's. 2 times 2 times 2 times 2. And what I'm going to do is I'm going to take the pairs out. I have a pair of 2's that go to the outside, another pair of 2's that go to the outside. When I have two numbers on the outside, I just multiply them together. Notice I have nothing left inside, so I don't have to write a radical. I just have 2 times 2, which is 4. Make sure you do number 2 for me. When simplifying radicals, we look for pairs of the same number under the radical sign. These can be simplified and a number can be brought out from underneath the radical sign. Anything that is alone, say that, is left under the radical. Alright, so tougher problem, let's look at this. We have 8 radical 27. We're going to look at radical 27, I'm going to break it down. 9 times 3, 3 is prime, 3 and 3. Okay, so I have this 8 on the outside, I'm not going to forget that, and then inside my radical I have 3 times 3 times 3. Alright, so I'm going to take this pair of 3's, it goes out. Already outside is an 8, take this 3 out with it, and then radical 3. So now outside I have 8 times 3. I'm going to multiply those together. 24 radical 3. Alright, number 2. Radical 5 times radical 8. That gives us radical 40. Okay, and now I'm going to break this down. 4 and 10, 2 and 2, 2 and 5. All those are prime numbers. Okay, and so now I have 2 times 2 times 2 times 5. I'll take out my pair. I have a pair of 2's. It goes to the outside. Then I have 2 and 5 without a pair. Okay, they're left alone, so they will be multiplied under the radical. Okay, notice number 2, we combined radical 5 and radical 8 to make radical 40. We're allowed to do this since both numbers were inside the radical. We can also combine numbers that are both on the outside of the radical, just as we kind of did with number 1. The only combination we cannot make is the number outside of the radical with the number inside the radical. Okay, so looking at number 3, radical 14 is inside the radical, 9 is outside of a radical. Okay, we can tell because the radical, if it were inside, it would continue to be over it. Okay, so when we multiply this, we will multiply the numbers outside the radicals, and just like our variables, if there's nothing written in front, then it will be a 1. So we'll multiply the numbers outside the radicals together, 9 times 1, 9, and the numbers inside the radicals together, which would be 14. Remember to always check to see, can you break this down and find a pair? With 14, you cannot. There would be no pair. Okay, so number 4, looking at it, we have the rule, and I just say inside by inside, outside by outside. So inside by inside gives me radical 100. Outside by outside gives me 18. Okay, and then I'll simplify. Well, 100, I know that 10 times 10 is 100, so I have a pair. So now I have 18 times 10, which is 180. Alright, I'm going to do number 5, and then I'll have you do number 6. So number 5, we have negative 6 times 4, which gives me negative 24. And inside I have radical 3 times radical 8, which gives me radical 24. I'm now going to simplify radical 24. So 12 and 2, 6 and 2, 2 and 3. Okay, so I have a pair of 2's that I get to take out. So negative 24 times that 2. And then I have 2 and 3 that don't have a pair. So they are inside. So negative 24 times 2 is negative 48. Radical 6. Okay. Do number 6 for me. Okay. Alright. And then we'll make sure that you go through these, do the trees, understand, don't take any shortcuts, especially this first day as we're learning it, and then we'll adjust as we get a little bit better at finding those perfect squares and simplifying these radicals. See ya.